Hi everyone, in this video we are going to talk about eudiometry, which is the study of gases. So in this type of questions, what we need to first understand is that the mole ratio is equals to the volume ratio, right? So we are simply talking about gaseous systems. So what we are saying is that just simply by comparing their volumes, we will be able to figure out what are their mole ratios, and this follows the Avogadro's law. So let's take a deep dive into this type of questions. So the first thing that you need to do, right, for any types of eudiometry questions is to balance the equation first. So I'm going to walk you through how these equations are balanced. So first and foremost, alright, if we consider the coefficient of CXHY to be 1, right, we will need X CO2. I'm going to balance the carbon first. And after which I'm going to balance the hydrogen, so it will be Y over 2. And after that, I'm going to balance my oxygen. So since I have 2x oxygens over here, Y over 2 oxygens over here, so since this is O2, this will simply be X2x plus Y over 2, the whole thing divided by 2, which you are going to get X plus Y over 4. So this is the first thing that you need to do, alright, to establish the different mole ratios. After which, you need to understand what is going to happen at each individual point in time. So if you take a look at this box over here, you'll realize that I have not put any state symbols here. Alright, so because water can exist as gaseous state or liquid state depending on the temperatures that we work with, and these are the temperatures that are typical of such questions. So let's take a look over here. So at the start of our reaction, we actually have CXHY gas, and we have O2, which is in excess. Alright, and what happens is after combustion, okay, so after the combustion process, there's a badly drawn fire, right? You will get CO2 gaseous, H2O gaseous, right? So this is still very hot. I haven't cooled it down yet. Okay, and at the same time, you'll realize that since O2 is in excess, you will have excess O2 over here. So maybe I will call it unreacted O2. And maybe what I can do is to change this into O2 reacted and O2 unreacted. Alright, after which I am going to cool it down. After I cool it down, water is going to turn back to the liquid state. So since eudiometry is the study of gases, water leaves from our system. So we only measure all the volumes of gases. And finally, we will pass it through an alkali solution, which is going to remove our carbon dioxide, or even if you have sulfur dioxide and things like that, they will be removed. Okay, and you only have O2 unreacted left. So simply by looking at the ratio of the different volumes of the different species, right, you will be able to figure out what is the mole ratio. So for example, if let's say my first value, alright, I've mixed 10 cm cube of this, and I realized that after the NaOH step, alright, I lost 20 cm cube. So what this means is that if I compare these two, the thing that is missing is carbon dioxide. So this will be 20 cm cube, this will be 10 cm cube, and so the ratio will be 1:2, hence the value of X is 2. So that's how we can go about tackling the question. So it's very important to know what the question is talking about. Is it talking about the cooling stage? Is it talking about the addition of an alkali? Or is it simply talking about expansion or contraction of values? So let's say the question talks about contraction of values. Right, so what you can do is use this idea of delta V is equals to V final, volume final minus volume initial. So let's say they tell you that, you know, after heating it and cooling it down, it shrank by a certain volume. Right, so if you look at the final volume, it is only the volume of CO2 and the volume of O2 unreacted. Okay, so this is your volume final, because this is what you have at the end of the mixture. And what you have at the start, it is your volume of O2 unreacted plus your volume of O2 reacted along with your volume of your hydrocarbon or volume of your fuel, okay, whatever that is. So simply using this, you can find out certain parts or unknowns in the equation. So you'll always be given the contraction or expansion value, then you just have to use final minus initial to figure that out. And what you'll realize is that the equation allows you to cancel away the volume unreacted, and this will allow you to solve quite a number of things over here. Alright, so with that, that is the concepts and ideas behind eudiometry. So use this idea of determining what the species present at each stage, right, to know how to solve different eudiometry questions.